Hey everybody, this is Larry. This is me going Q4 of the weekly contest 433, maximum and minimum sums of at most size K sub-arrays. Hit the like button, hit the subscribe button, join my Discord, let me know what you think about this one. I think this is very similar to problems that we had last week and a week ago, so that's what, and honestly even then it took me about 40 minutes, but some of it was just on silly debugging, so it's fine. I think the live portion is very long because I solved it live during the contest and it took 40 minutes. It's as fast as I can make it, all right? But I think it's worth watching it a little bit if you after the explanation, maybe on a faster speed, because I solved this intentionally I solved this without the K constraint so that I can verify my ideas and then solve it with the K constraint. You know, it's very tricky, but to me anyway, but that's the idea. Okay, so the first of all, n is 80,000, still too slow for n squared, I think. I don't know, maybe not. Who knows? A lot of people got it very quickly. So yeah, and of course you have to deal with negative numbers, which is how I spent 10 minutes debugging, because I used the wrong sentinel. But my code is actually very probably too short. But okay, first of all, this is a sum of the max and the min subarrays, right? So the reason why I talk about this is I actually talk about this in Q2, I think. Is Q2 the one with the subsequence? So I talk about it in Q2, right? The way that I would think about it is that you can separate them, right? And why can you separate them? Well, if you write out all the sum, you write out the sum as a bunch of additions, like 3 plus, you know, this, or maybe you want to write out the answer of the max of this subarray plus the max of this subarray, ... And if you have a subarray, the contribution of this subarray is equal to the max plus the min, right? But that means that in a way, and maybe I'll write it out a little bit, right? So maybe you could say, you know, contribute from say I to j is equal to well, the contribution of the subarray from I to j inclusive. That is of course equal to max of ij, not max of ij, but we just call it as a function, maybe f of max, maybe that's a little bit clearer, plus f of min of ij, which just means the max item from subarray from I to j inclusive, and the min, right? I mean, you know, I hope I don't have to write it out that clearly. But if you kind of collect all of the if you collect all of these together, then you'll see that because everything is linear, you can just put all the max on one side, right? So that, and then all the min on the other side. And then once you separate that out, then you realize that, well, they don't interact with each other. So that means that you can solve the max and the min at the same time. Or sorry, at different times, and it's okay. Okay, so I am going, for the most part, the max is going to be equal to the min, right? The idea. So I'm going to just go over the max for this problem. And I'm just going to bring up the drawing board. Yeah. I'm just going to focus on the max, but you know, without loss of generality, you can focus on the min. And my code actually reflects that. But yeah, but the idea here is that, of course, now this is similar to Q2, but it is a subarray. So what does that mean? So usually for subarray problems, I think about things in terms of contribution. I know that there's all these things, and sometimes sliding windows think of this, but yeah. And what I mean by contribution, right? It means that, for example, I'm just looking at the example. Okay, well, the examples are kind of crap, so it's fine. Like maybe we have something like, you know, whatever, right? Then the idea here is that, okay, if our number is 2, what is our you know, we pick a random number, whatever, an index. We go, okay, well, what is the contribution to the answer where 2 is the max? In this case, it's the max. You know, like I said, you could do the min separately. So for the max, where 2 is the max, right? And that's really the idea of contribution. Where and yeah, and you could calculate this in a number of ways, right? I mean, I know that I said that and I'm like, oh yeah, that's it, of course. But the idea here is that, okay, well, what is the contribution to the answer? And the idea first is then you would have something called a monostack. And monostack is a fancy term for monotonic stack, and I don't even know if it's increasing or decreasing. The reason why I never think about it that way, monostack is just a useless term if you ask me. I just think about it as stack, and it's a stack with a property where, well, it does actually come into play with the monoticity come into play, but the idea here is just the invariance, right? And meaning that, okay, so there are two things. Right? One is the stack. We want to use this data structure of a stack to answer future questions of how far can I go to the left where this number is the max, right? That's basically all I want to be able to answer. And this input is actually a terrible input. Let me rewrite another one for demonstrating. I mean, for example, you may have I don't know. Let's make it like 3. I don't know if this is a good one, but in any case, and we're trying to get max, right? Well, okay, so 1. Okay, so when 1 comes into play, 1 is the max. Okay, fine, trivially true. And let's go -3, right? Well, what happens with -3? Well, with -3, well, you just push it on the stack is the short answer. Why? Because if you think about it in terms of segments, 1 is the max for this segment, and then the 3 is the max for this segment, right? Okay. Okay, now we have 4. What happens? Well, 4 is actually the max of this segment, right? And the way that we do it is by popping -3. And why do we want to pop -3 as well? Well, okay, actually it is more than that. But first you pop -3. Because we know that in the future, there is not going to be a segment where -3 will dominate, right? And what I mean by that is that, okay, there are probably ways to visualize this but I just for this one I like to just brute force enumeration. So you have 4 and you have -3. Let me space them out a little bit more. Right, so that means that there are 3 types of numbers in between. Let's say the number is 10. Well, if the number is 10 is coming up, which is bigger than 4, well, excuse me. Well, 4 will never be the answer, but also or 4 is not the answer, but -3 will never be the answer, right? And then another case is if it's in between, right? If the next number coming in, it's say, I don't know, 2, right? Well, 4 can be the answer, but because -3 is on the left of 4, -3 can never be the answer, right? And then finally, just to be exhaustive, and yeah, maybe it's -10, right? It's smaller than -3. Well, in that case, 4 is also the answer, as -3 can never be the answer. So no matter what number in the entire number line that is coming up in the future, -3 can never be the answer. So that's why 4, I like to think of it as yeeting, like Pac-Man. It's just a silly thing. I don't know. It's a Larry thing. So it yeets the -3 off the stack, right? And then the next number, again, well, it's a 1, right? So same thing. We yeet it off the stack. So now 4 contains this segment, right? And that's how I like to think about it. And the reason why I like to think about it is actually it comes into play even more in the for this particular problem, is this visualization. So then now you can think about 4 as dominating the answer for that long. The reason why this is important is, and we'll talk about this in the future, right? Because it needs to be solved for this problem. And anyway, so then now you have -2. And keeping in mind that for now, we do not need k. Or we're solving the problem without k as a concern, right? So I'm just showing you what gets happen when you use the stack. If you know everything about the stack, you can probably skip ahead a little bit. But yeah, so you have -2. -2 is not going to beat 4, but it can be the answer in the future, right? That's why we keep it. For example, if the next number is 0, then actually, no. If the next number is -10, then -2 is actually the minimum number up to this segment. Of course, if you keep going, it's going to be 4, but it can be an answer for a solution. So that's why you would push on the stack. And then now with -1 is what we said, and -1 actually yeets the -2 if you're curious. And this is the new thing, right? Anyway, okay. So let's say you have the stack set up. You're like, all right, Larry, I know mono stack. I get the idea. How are we getting the answer? And also, more importantly, how do we get the K? All right, let's do it without the K first, right? Let's figure out, still without the K, how would we do it at this point? Well, at this point, without the K, we want to say, actually, without the K is kind of hard too, but like in a different way. But you have this idea of, the reason why, yeah, it's a little bit tricky actually, without the K, but it's fine. But the idea here is that, okay, without the K, what is the, if we add -1, what happens? Well, there are actually two parts to this contribution, right? One part is -1 is the biggest element in which we have the segment for. And then the other is, well, we have this segment because you can think about this segment as at the -1, you can think about it as if we want to take a range, maybe just a different color. If we want to take a range of this, say, well, that is still 4. So, yeah. So that means that in a way, if you want to rewrite this entire thing, you can think about this as this is also a 4 because that's the contribution to the final answer. This is a 4 and this is a -1 because that's the contribution to the final answer of this range, right? So then in that sense, now you have two segments for you have two segments, one where the thing is 4 and length 3, and then you have -1 length 2, right? Oops, how did that happen? All right, maybe my pen's a little bit stuck for some reason. All right. Okay, length 2, right? And so without K, then you just have to sum this all up. And the way that you would do it is with prefix sum. I'm not going to go over it that deeply, but it's just about, because the idea, the prefix sum just allows you to get, okay, how many 4s are there that we have to do, right? And the reason is because, yeah, if you look at this particular range, if you extend one more, then that's another 4, right? And so forth. So that means that all the previous contribution will get added up with K, right? So then now, technically, when you do -1, all you have to do is just add up all of this, which is actually the prefix sum, right? Because if you keep track of the prefix sum, then here, this would be 12. This is -1, -1, so this is 10. And as a result, you just add 10, which is the sum of... So, yeah, so far so good, hopefully, in explaining the contribution of each answer. So how would you calculate this? The way that you would calculate this prefix sum idea is just also on the fly, right? Let me rewrite the same thing, but starting over with the prefix sum. Because then now, if you write it again, actually, let me change the color this time. If you write it again, then now you have a 1. So what happens? Well, this segment has 1, length of 1, so that means prefix sum is going to be 1. Okay, -3, you have another segment, you have -3, the length is 1, the prefix sum is actually the previous prefix sum plus this segment, right? So pretty straightforward, right? In theory, this is just the prefix sum is -2, right? And then 4 gets interesting, right? So you have a 4, as we said, we want to yeet, right? So now we have this segment. The value is 4, L is equal to 3. Of course, you can do the math and say prefix sum is actually 0 before, with no element of 0. So you have 3 elements, so this is 12. There are other ways to do it, but that's really the idea, right? You take a look at the previous, and before that it is 0. This is not super clear, but if you had other previous segments, then it's just the prefix sum there plus this thing, right? Because that's how you do prefix sum. And as you pop, that's how it comes up. I mean, maybe it'll be clearer when we kind of add more numbers, because when you have -2, for example, then now you have this one segment, -2, L is equal to 1. The prefix sum is just 12 plus -2, or the sum of the segment, right? So this is just going to be 10. And then now you have -1, which is maybe a little bit interesting, because then now you yeet. Larry is hungry. Maybe that's why. I'm kind of hungry right now, honestly. But yeah, so you yeet. So -1, L is equal to 1, right? Sorry, L is equal to 2. The length is 2. But now the prefix sum part is just going to be, it's going to take off here, right? Because this is the previous segment. So it's 12 plus -2, because there are 2 elements of length 1. So this is prefix sum, it's 10. Actually, it's the same prefix sum. That's interesting. But anyway, right? So that's basically how you build out this prefix sum. Okay, so now, hopefully, I mean, maybe you can rewatch if it's still a little bit short, because, this is a very long video. But that's how you would get the prefix sum. And then to without k means that you want the entire array. So then you just sum up the entire array, which is the prefix sum part, and that'll get you the answer, right? Pretty straightforward with there's no k. What if there's a k? Well, that's okay too, right? Now we have, let's say we're able to build this out, then now we just have to do a query of the last k items. And actually, now that I think about it, I didn't do this during the thing, but in the same way that you could have done it last week, you could have also did a sliding window, maybe. Yeah, you definitely could have done a sliding window on this prefix. Yeah, and if you did, then you could do this in linear time. Okay, maybe I'll upsolve this later. But in any case, the way that I thought about it is with binary search, which is that, okay, well, if k is equal to 3, then now for -1, we want this sum. So, I mean, I'm not going to go over it in detail, but it's just that now this blue part is just this equal to this purple part, the big purple part, minus the small purple part. So then it's just about binary search and then making sure that you have the indexes right. That's the core part about this problem, is that then now you binary search, you build these, and there's some if statements to kind of deal with, like, okay, you binary search, you're at this chunk, but then you also want to minus, because this chunk is part of a segment, right? So then you just have to, do some maths that way, and that's really the idea for this problem. Yeah. I mean, and of course the min will be the same-ish idea. But yeah, anyway, so that's pretty much the idea. And here I actually wrote the code so that I do less than equal to and greater equal to, which means that I do both the max and the min with one function, because it's the same idea. You just, it's just this function is a little bit different of what pops off the back of the queue. Well, actually it's a stack, but I thought I might need it, or I thought I wanted to use it a queue. But yeah, yeah. Yeah, that's the idea for this part. Anyway, it's a stack. Maybe we'll upsolve this afterwards. Yeah. This annoys me in terms of explanation. Let's change this real quick. I think one thing that I didn't mention though. One thing that I didn't mention is that wow, I do this in a lot of places. Yikes. Sorry, friends. Hang on. Almost done. Probably. Let's give some just to make sure that we are actually done. Okay. I think one more thing that I actually did forget is that if you look at here, right? The thing is that well, there are two things. One is that X is actually monotonically increasing or decreasing depending on which version you are. Oh, I highlighted, but I have this up. But actually, it's not interesting, right? So, actually, I didn't realize this until now. That's why I'm like pausing a little bit. Yeah. X in this case is a monotonic stack, but actually it's not interesting. It's not what's needed. What we're binary searching is just actually on the index. And actually, index is also monotonically increasing. And it can only be monotonically increasing because it just contains the index. And we're always removing the biggest index. So, and adding, when we add, it's always going to be the biggest index. So it's always going to monotonically increasing. So that allows us to binary search with a stack. And that's it. With this binary search, we have everything that we talked about. And yeah. So first, yeah, I do a sentinel value of -1 with an impossibly big or small value, and the prefix sum and the prefix contribution. Actually, do I even use prefix contribution? Huh. I thought I did. Maybe I don't. I think I did at some point, and then I rewrote. Oh, I think the no K version needs it, but this one does not. So yeah, maybe I could just do that because I don't use it. Well, it doesn't seem like it. Okay, easier to explain. I think on the K one, I needed it for maybe just making it slightly easier. But in any case, yeah, this is the for each item, we pop off the back of the stack as we talked about, right? And then you have the contribution. This is the contribution of this entire segment. Again, this is before we do the math. This is just, we ate all those things. So then the top of the stack is going to contain the last index that we haven't eaten. So that's how we have this thing. Technically, it is, yeah, okay. Because you don't include this number, so that's why there's no like +1 or anything. It's exclusive on that range. And then X is the current value, so that's why we have this. Previous is actually previous prefix, right? Let's write that out a little bit so that's a little bit clearer. Right. All right, just want, this is TDD, right? Yeah, so the previous prefix is just the top of the stack, and we store the prefix here as we talked about. So then the current prefix is just, well, this segment's contribution and the previous prefix, and then we just add it to the thing. And so this now just allows us, this gives us the entire prefix sum of all the, excuse me, previous numbers that we cared about, right? And we want to binary search for the left index. Of course, you cannot go beyond 0, which is why we have this max is equal 0 here. Yeah, and then we binary search for the index. Here is how I got, I don't know, I forgot that you can have negative values. I just didn't pay attention enough about it. So I didn't have a high or an infinite value, which is how I binary search, and it gave me the wrong answer for a little bit, which is why I took 10 extra minutes. What a silly boy. But yeah, but this gives us the index of the last, of the segment that does not include this number, right? So for example, if you're searching for index 2, then it's going to return the segment that's after index 2. So that means that, yeah, and then everything else is just maths, right? So this is the chunk where this is everything from the current index, the end of the prefix sum, minus this thing, which is the prefix sum of the index that we don't want to count, because that's what we search for, right? I mean, you have to, I recommend if you're going through this at home, also draw it out and go through it slowly, and you'll kind of see the segments. So yeah, so this is the prefix sum gives us the whole segment, and here is the leftovers calculation, right? So that's basically the idea. This is the value, this is the index minus what we're searching for, keeping in mind that, yeah, again, if you draw it out, it should be, I think it's clearer, and times the value of the number of leftovers that we care about, right? So that's pretty much it. And then you add it to the current, and that's it. Yeah. This is going to be O of n log n just because this is O of n. But there is a binary search here. So yeah. And we do 2 of them. So this is going to be n log n. Now that I think about it, there is actually an O of n solution the same way that, keeping in mind that last week, now that I remember this part more clearly, keeping in mind that last week, this is the problem that I spent 4 hours on, 5 hours on, and this week maybe I only spent 40 minutes on, so maybe that's an improvement. Even though I forgot about the other solution, the O of n solution, which is what we are going to do now, right? If you want to watch the live portion, you can also skip ahead, of course. You have the technology. I believe in you. But yeah, so the idea behind that is actually to use a queue. So then now we have the sentinel value, we have the beginning index, and then the end index. Right? Yeah. And then here, well, yeah. And then now all we care about is the inside sum of all the things, right? So then maybe you have an inside sum value. And then now here, when we pop, what happens? When we pop, well, we have to adjust inside sum. I think that's the short story. When we pop the inside sum, we subtract it by, I guess actually we don't need the prefix inside anymore. Also, why is there an extra 0? Maybe I forgot to remove it when I remove it from the other. Oh, this is just a binary search. And this is not needed because that's the contribution. We said that we don't need it anymore, and we don't. Okay. Okay. With that change, let's actually run it real quick, as we said, right? So yeah. Okay. Huh? Did I change something else? Oh, value is sentinel. I have 2. What the? Oh, it was this, and then I fixed it to be raw. Okay. Oh yeah, because for Q, we want to. Well, I want to do so starting index and end index for the thing, and actually we want to lie and use an array, and also we want to. Now we actually want to keep track of the prefix sum, which we didn't for. Do we need the prefix sum anymore? No, but we want the segment sum, right? So actually it's not the prefix sum, it's the segment sum, right? So here the segment sum is going to be 0 because. And actually I don't think we need the sentinel anymore. So yeah. And we do this thing anyway, so. Yeah, so then it pops. From the end, and then we pop it. Oh, this is pop, right? Q. So then we look at the last element. We look at the segment sum of that last element, and we subtract from it, and then we pop. Good so far, I hope. And then now at the end, we do the contribution, which should still be the same. The previous prefix, we don't use prefix anymore, so we don't care. We don't care. So then I is going to be the leftmost element. So it is just the previous. Well, I want to write something like the previous, but without a sentinel value is a little bit wonky actually. but this can happen. So yeah, we just have to keep track of a few things. That's all. Hang on. Let me slow it down. But okay. So inside sum, right? Okay. Inside sum is fine. I mean, this would be so inside sum would add the contribution. But even this part isn't quite right because that may be 0, right? Or that may not exist. So what we want is keep track of the leftmost is equal to I. When we eat stuff, we go is equal to, well, the new previous leftmost index, right? Yeah, and that's it. If we don't eat anything, then by default it's going to be 0, and only the first element never eats anything. So I think this is fine. Leftmost, right? And then yeah, contribution here. We append a new thing. We go leftmost. We go I. We have X is the value, and then we have the contribution. We don't need prefix anymore, right? Of course, this is a Q now, and then now we want to care about. But yeah, basically, while length of Q is greater than 0, and the beginning of the array, if the index is greater than left, oh sorry, smaller than left, then we have to pop or do a fake pop. Then yeah. Then now 0, right? So that means that we want to increment this one by 1, right? And then inside sum, we want to subtract it by the inside value of this thing, which is going to be 0, 1, 2, 2, right? And then also the segment sum, we want to subtract it by also the value, right? Maybe I could have done that in a cleaner way. But yeah, and then yeah, and then if this element is greater than the second element, which is the range, then we want to pop left because now it's no longer bueno, right? Also in that case, technically segment inside sum would be 0, so maybe you could check for that instead. Okay. And technically this will be an if statement, but that's fine. I'm okay with it. Anyway, and then now total just equal to inside sum. Ooh, this is very wrong. But that's okay. That's part of the exploration. That's part of the learning. I can realize I forgot about last week already. Honestly, that I forgot that I spent 4 hours on it and still got it well. Yeah, oh well. Okay, so inside sum. This isn't quite right. This isn't the contribution 0, 0. Leftmost, maybe there is this +1. Maybe that's why. Okay, so this fixed the 146 thing, but the -6 is way no bueno. Let's just focus on one part at a time. This is this is the max part. Is the max part right? Okay, so contribution is 1. Yeah, that feels right. -3, the contribution is -2, doesn't feel right. So the inside sum. So 1 put no -2 seems right. Yeah, because that is the inside sum. And then you have 1 in which you add 2. That feels right, right? Okay. So that means that maybe it's the other one. I don't know. Oh, it has to be the other one just because, you know. Okay, so it's min. Now we're doing min. Right? So 1, contribution 1. Okay, fine. -3, contribution. That's fine. 1 should not. This should not happen. Did I mess up something with the function? Because we're talking about min, then -3 should still be in there. Oh, I compared the wrong element. Okay, that's fine. Because we shifted elements. I didn't look at this part. Did I look at everything else? I think everything else I wrote, this stuff I wrote just now, this is the only part that changed. Right? Okay. Yeah, and that's pretty much it. If it's right, if it's not, then I have to keep going. But yeah, so now you, as you can see, this is linear time, linear space. And yeah, that is all I have for this one. Maybe I could clean this up a little bit, honestly. But this is also, honestly, the same idea as last week. So it's a little bit awkward. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live in the contest next. Mistakes for sure. Okay, so people already finished Q4, so I'm really slow today, apparently. Or maybe not as fast as ChatGPT anyway. But alright, let's go. That is not Q4, is it? Oh, it is. I just, because that is an earlier problem, right? Oh, subarrays and subsequence. Okay, so that's why. It's just very confusing. Also, how am I 91? 91 people got 3. Oh, because a lot of people got Q4. I don't get it. I see. Man, I am slow today. Alright, well, I'm gonna be slow if you keep on looking at that. Oh yeah, because my internet was down for a little bit. Okay, let's see. At most case subarray. Okay. Well, not gonna be top 25 today, but okay. Almost 200. I feel like we did this problem at some point, but maybe not. Maybe not with this as the function. And it can have negative numbers, which is actually kind of wonky. But so they're n squared different things, so it's contribution, contribution, contribution. Alright, let's focus on just max. What would just max look like? It's just, it's kind of, I expect, okay. What would max look like? So contribution, does this contribute to, this contributes to the max in at most that number of arrays. I mean, it's going to be a mono queue, I know, but I'm trying to figure out. I feel like I'm very weak on mono queue lately. Okay, let's just focus on max, and then I think the generalization shouldn't be bad, but maybe I'm wrong on that one. Okay, so then, okay, if we're focusing on the max, if this number is bigger than the previous number, then the previous number can no longer be the maximum element. Okay, fine. Is greater or is less than q. Oh wait, no. X, then q dot pop right, or just pop. Okay, and then q dot append x. But then now, so we would be mostly done if this was on max. We're going to figure out the min as well, and they're not. You can't separate them out, can you? Actually, you can, right? Maybe you can. I don't know. I feel like if you can, then it shouldn't be that bad. But I don't know if I'm right about that one. Okay, let's try it. Okay, so what does this mean? This means that for okay, so contribution. So this means that this contribution is just going to be, so this is the max only going up to the previous thing, right? So Q actually should contain two things really, an index. So then the contribution, it's going to be is it a queue? I think this is a stack actually. I think I messed up, but we could still use it as a queue. This is the last index. The current index is I, right? So then it's just this times X, right? I think I think this is a stack. I messed up, but that's fine. Oh yeah, this could be 0. That's why I kind of wanted a sentinel, which is why I said this is actually a stack. And this is infinity and maybe -1. It's fine. Why am I such a noob? 14 and 0. Again, this is the same thing. I don't know about this part though. Would this be 0? -3, 1. Why would this be 0 though? Is it because I have a min of 0 or something? Or? Okay, so then X is -3. I'm looking at this thing really, that's why. Oh, K is at most 2. I forgot about the K. So if there's no K, this is easy. But because there is K, that's why. Because I'm counting the extra 1, I think, maybe. I don't think, actually, no, this should undercount it, actually. So the contribution actually goes backwards as well. That's what I'm missing. No. If this is the last element, but then now you want to sum up all the elements that were already in there. Because then this is the last element and those were the subarrays that extend. Okay, I think that's fine. But that isn't in general case. That doesn't take account the Q case, the K case. I mean, that's fine. We just have to prefix some binary search. Okay, yeah. Yeah, okay, that makes sense. Actually, that's why I had to change to make it a stack. But okay, so we are okay so far, but now we want to prefix some. So actually, so here we want the prefix sum to be 0. We don't care about these. We want to say, okay, we don't care about it. That's fine. So then the prefix sum is just going to be and this is actually not total, but this should be this plus okay, let's say contribution is going to be this, and that's fine, assuming that it goes all the way, and then it's contribution plus the last elements Yeah. Oh, this looks very awkward, so let's separate them out. I know that we don't take account of K yet, but that's fine. We could binary search for it. It's the same thing that we did like a week ago. What I'm looking for is that this should be for infinity. This should be either one or it should be 2. I'm expecting this number to be 2, but it's not giving me 2, which is not great. Because it's wrong, but it's wrong in the way that I would expect it to be. Let's refactor that really quickly. That doesn't change anything. Okay, so then we can print out the Q real quick, and yeah, okay. Okay, we print out the Q. Are we okay enough? And also, yeah, okay, that's fine. Maybe just a I contribution Q. Okay, let's go. I contribution. That's definitely wrong. Oh, whoops. This should be 2. Oh man. Okay. Okay, so let's just also have X. We have an hour. We can finish this. I'm just slow. It's fine. Okay, so -3. The contribution is -3 because there's only 1. Okay, this is going to be for 2 array. Oh, we have to worry about. How did I do that? Wait, sorry. I had the idea about it's not prefix sum, but I think I'm undercounting it in 2 places. One is just that they're equal. Equal we can fix. It's just that if this is this, that's an easy fix. But the other one is actually not counting that -3 going to 1. Oh, that's where we need the idea of total counts inside the stack. Because every number that's inside the stack would then now get to be bigger by 1 with this number in it. Yes, I had that actually. So total inside, we want to add that by X. But here, every time we pop, we subtract it by the X that was inside. And then now we have the total sum. So then now the contribution is this plus total inside. Because all those numbers, it's not just that. This is wrong. Because it's total inside and the length. Because that is hard. So then actually it's the sum, it's the prefix sum. Actually, in a weird way. There's too many dimensions for me. We'll get it, but it's still too many dimensions for me. Okay, so total inside. So that means that the previous one will go up all the. Because basically it is the length of the contribution. Okay, yeah, it's just the contribution, I think. What are these anyway? Value, index, prefix sum, and not the prefix sum, the contribution, because the contribution happens every time you extend one character. Okay, that's fine. 1, 2, 3, and then contribution. Okay, come on, give me a 2 or 3 maybe. I don't know. Maybe this is too much. Why does it think that? Okay, so this is 1. This is a contribution of 3 because, oh yeah, because we also got rid of this one. So actually that makes it a little bit wonkier. It's 8, right, for the first one? I don't know. Even in my wrong way. Doesn't seem like it, because max should be, even if you don't care about k, you don't care about k, then it should be just, what is that? Contribution with 3 is going to be 9, 1, 2, 3. Wait, then why would it be? Is total inside wrong? I don't know. Maybe total inside something wonky. Yeah, total inside should not be negative. So I'm not adding, because I'm not adding total inside, is that right? I'm being dumb. Okay, 14 is right, 2 is what we expect. Okay, okay. Is 2 what I expect? Yes, because basically it's just this plus 1 more index 3. Okay, okay. So I think we're right if we have infinity k's. Now we have to do k is equal to 2 or whatever. And that is just, yeah, the same thing we did the other day. I just don't like to do it. Okay. Right. Okay, so how do we do it? So we want the up to previous k elements. So this is the contribution, everything is fine. We just have to fix this part. Yeah, okay. And the queue is not a queue anymore, but whatever. So we binary search on, okay, so the current index is I, we binary search on I minus k, and that is the longest extent, right? Yeah, okay. So we do oh, the value at the first element is not going to be Gucci. Yeah, well. I should have thought about that before, actually. Yeah. I need to be better about using these variables, because I feel like that is going to be, I'm going to have a typo. So I only swap 0 and 1. 0 and 1. Okay. Let's double check that it gives the same thing real quick. It's easy to mess these up. No, that's definitely a thing. Is it because no, something messed up. 0 and 1. Oh, because I didn't swap this thing, even though there's no 0 and 1s. I'm just very blind. Okay. Nope. Oh no, Larry. Previous 2 is right. Okay, that's fine. Oh, I see, because I double counted the contribution. Okay. That is fine, I think. Yeah, okay. Okay, so I can put it at the end, I just have to do it this way, but okay. And now we want to bisect I minus k, right? So it is exactly the same. What does that mean? So this is the index in which it's starting, so that's the segment. how many people got it? So, I'm a little bit tired. Wow, a lot of people got this one. 83 people got it already. I mean, I guess it is the same code as like the last 2 weeks or something. It's just that I have, I don't know, I'm being slow. Okay, right, so then now index is equal to this. So then now this will give us, so the index, so the prefix sum contains all the stuff that you need, including this. So that means that the okay, current prefix is equal to contribution plus previous, where previous is this, right? So then it is just going to be q of index of 2, so current prefix minus this will give us everything up to it. Okay, that's good. I think that's what we want. Okay, so that's everything up to it. And then we have to get out the extra parts, which is going to be just index math, right? So it's this plus why do I use total inside again? Okay, so it's just going to be this plus we have to do total inside somehow after this, but yeah, okay, so it's this plus the delta of the index. So it is going to be, or the next index, which is actually kind of awkward. So it actually is q sub index of 0 is the index. And this spans up to the next one. So it is index plus 1, actually. If index plus 1 is less than length of q, then yeah, so if this is not the last element, then you I think maybe it's just easier to do it here. If we append the Q item already here, then now, okay, and then now this is maybe not, maybe I'm doing too much. All right. So is this item so that's the next index. This -1 is inclusive. So then is this minus I minus k. No, the other way around. No, this I minus k plus 1, which is why you can maybe take out that -1, but times q of index of 1. Otherwise, if index plus 1 does go over bound, then you are at the We do need to add this actually before the thing. Before the binary search, because it could be this item. Okay, so otherwise, did I do the math wrong? It should be this plus -1 actually. Yeah, I think I did the math wrong. Okay, so that's why I'm getting confused. And then now this should always be true. Okay, but we have to take account the total inside, but let's run it real quick. Maybe my head is not good for this. That's not great, obviously. We deal with this number, so that means that we're probably dealing with something here. Ideally, this should always be 0. If no, it should never go to this value. Why? Oh, because it's -1 to get the previous one. So we're searching for a 0. Well, we're searching for negative numbers, so that's how that. That's actually annoying to fix. Okay. Actually, then why are we searching it? Where's I minus k? Bisect. Oh, let's max this by 0. Okay, not great. They should always have. Oh no, this is not great. Q I minus k. Why is it giving me crazy stuff? Okay, so this is -2, so that's fine, right? What are you doing? I mean, I think the idea is not that bad, but I'm struggling for sure. Current y because index +1. What is index? Well, this will go up to the previous one, so current is equal to at least that's something, right? Okay, so that's current is 1, that's fine. Where are you getting this from? Why is index 0 for, oh, because it's -1 to get the previous one. Okay, this is the, oh no, this is not index, no, it is index +1 is the one where you binary search for. So this one should be inbound. Oh, because I didn't max this part. Okay. Okay, is it better? I don't know. But zero. This is the Q. 1. I don't know what I'm looking at anymore. So current. Okay, this is not great. So 2. It removes the 1. It binary search for 0 probably. Yeah, search for 0, it should find 1, so then it goes to the previous element. And it goes from, so -1 goes from 0 to 1, which is actually, which is not true, is it? Am I removing things wrong? Because basically 1 should be in there. It just doesn't extend very far, it just extends it by itself. So this pop is doing something funky. Two removes the 3 because it's no longer possible, which is fine. Or 2 removes the 1 because it's no longer possible. Maybe this isn't easy at all. I mean, yeah, but okay, so this removes that, but no, this is right, but well, the idea is right. But we're doing something funky for sure. Okay, so I left is 0, the total is really negative, current is really negative, because index is 0. Why? Oh, because it binary search for this, and then the previous number is this. The range, it should not have this number for that range. Maybe the sentinel value is stupid. Maybe this should be 0. Maybe infinity doesn't make sense for this case. You do get into this though, because now you removed everything. This part is annoying, but it doesn't represent it what it should anymore. Wait, does the 2? Ooh. I think that's my problem, is that this 2 does not represent the range where 2 cares about. It's not the next element, it's the previous element, right? 2 goes, so we binary search into the 2. The 2 is the one that gets counted, actually. I am really dumb on this. Okay, it's not right, but because then now the 2 goes as far as the previous index. So this is the previous index. The 2 extends this far in because everything after that. Okay, I did the segment in the wrong way. Okay, so actually that means that, okay, so no, then this is not -1 anymore. Okay, this is wildly wrong, but that's okay, maybe. Well, this should not be 2 for just the first element, right? Okay, so we have the prefix sum. Current prefix. Okay, so basically it gets the current index, but then the minus. So then that means that this should be -1. Should be fine. Minus left, maybe less fine because it's awkward with the -1. No, this is on the current index, so we actually don't. Yeah, maybe this is very weird framing. Still wrong, but okay. So then 0 total current is equal to 2 prefix sum. Okay, so this is 1, so this is returning 1. Because this is summing the entire prefix. No, I see. No, yeah, this should not. Well, no, it's fine. It's just that this should be this. I see. So that should be 0. Okay, 14, 12. Indexing is hard, right? Okay, so this is still wrong, but it's a different way of being wrong. Why is this wrong? One's contribution is 1, okay. Two's contribution should be 2, 4, so that's right. 3, it's really wrong, but that's fine. Because that should be capped by 2. So left is 0, which is very wrong. That's the reason why. I minus k. Do I read this one out somewhere? Oh, I minus k is 0, so I'm just really bad at this. It's a good thing we do it. Okay, so 11 and 1. Is that right? 6, 11 and 1. Okay, so I think we're good now. Maybe. I mean, maybe we have wrong answers, but it's half an hour. We should be able to do it. So we just have to. So this is the max side, and now we just have to get them. I feel like I'm missing something. The total inside, because the thing is that I don't think this is right, honestly. Because the thing is that it doesn't factor in all the other stuff that's inside that extends. Yeah, we definitely do not. Oh, wait. Maybe we don't have to? Because of the prefix sum, because we don't have to factor in all that. And if you do, then the total inside is factored in by the prefix sum. Okay, maybe that's fine. Okay. Fine, Larry. I don't know. If you say so. Okay, so that, now we have this thing, copy and paste. Wish I didn't, but whatever. Greater than Leetcode 2. Okay, I think everything is the same, isn't it? Just the min, right? And this already gets the min, it just gets the contribution. So okay. Oh, the sentinel is different now. 9 and -3. Okay, well, because I have a total is equal to 0. 20 and 2. Oh, -6 is a little bit sad actually. But yeah, okay. Let me get rid of this total inside thing since I don't use it. And this is why you try to minimize code redundancy. Yeah. Okay, so if I just do the min part, I mean, it's good that it's wrong now. It's better wrong now than later. So this part, the top part should give me 9 for min, and it does. Bottom is wrong because it should give me -9 plus 2 is -7. It only gives me -4 or -3, so it's off by 4. Okay, let's just do icon. I don't even remember what. I guess I just removed stuff. I don't even know if they're right, honestly, yet. Okay, so 0 is 1, that's fine. 1 is -6. Is that true? Yep, -6. But then now you have a 1. Oh, this is incrementing, so we might have missed the part where it is not. So that's good, I think, maybe. I don't know. Okay, so why does this thing is -2? Oh, because that's where the total inside thing has to. Because everything inside contributes to the answer for this one, because it extends, right? Because 1 could never be the max. So there is some weirdness here that I'm doing with this append. One can never be the max anymore, or the min, sorry. So 1 can never be the min. Of everything. Well, it could be the min 1. So it should give me a 1. Actually, it giving a 2 is actually not great. Oh, I see. I'm getting confused actually. Because then now we have to contribute it to the other side. I think maybe I'm just doing it wrong. I think the idea, because the thing is that the window has to be yeah, maybe I'm definitely doing the window wrong, because the contribution is that, okay, this is the last element, and then the next element will be the last element, but only everything inside that window. So can we do a sliding window every time? No, that's what the prefix sum is supposed to do, right? Am I just doing the math wrong? No, I'm doing the math wrong because let's see. Maybe I'm just doing the math wrong. I keep on convincing myself the same thing. Right, so 2, right? Okay, fine. Okay, so it finds the 2. It goes, okay, prefix sum, because its contribution should be, it finds the 2, okay. No, left, not the index. Okay, so 2 on the left, it should be 1. So it finds this one. So then we actually want this suffix sum of this, which is just the prefix sum of this minus this. The two-dimensional things are confusing me too much. Maybe this is a sig tree thing and I messed up on a sig tree. Because I have to get the prefix sum, right? So here, one end of the prefix sum is that, the other end is that. Okay, so it goes here. So the prefix sum of here is -6. I think that's where it went wrong, maybe. Okay, so current prefix q index of 2. So that's -5. That's good. Oh no, it's -5 minus -5. Also kind of what we expect. So then why is it so wrong? Why? So this should be -5 minus -5 is 0. Okay, that is, I'm just dumb, but okay. And then it's wrong in 2 ways. Maybe -5 minus -5 is right. You search for 1. Oh, because I bisect for this thing, but because there's negative and negative, I am dumb actually. Let's put this here too, just in case. Oh man, I have to use smarter sentinel values. Okay, is that right? Oh my, I can't believe I spent so long debugging that. It's like, I don't know. Okay, YOLO submit. It may be wrong, that's fine, but silly sentinel values. But I see why people were able to get it that fast, just because we did the same problems way recently, right? So I don't know, 197 people. How many people got this one? I mean, not that surprised, honestly, just because we've done similar things the last couple of weeks. I'm a little bit awkward on this today, especially on just I want to go back to the tape to see how long I spent on that part, but that's a little bit sad actually, because that was a while. Because I was like, oh, we're good to go, right? It was like 10 minutes, maybe not. Good job, Chi Chi. It's hard to give people shout outs nowadays just because the handles are so weird. So we definitely did not make it to top 100. A little bit of a sad day. 156 is okay, I suppose. I was very slow. I don't. I mean, some parts of it, my internet was also having issues, but this one I kind of knew how to do. I just kind of took too long. And honestly, at this point, I almost feel like people have libraries for it because we did it 3 weeks in a row, 2 weeks in a row, 3 weeks in a row, something like this. I'm just not practiced, so it's a little bit silly. But it's okay. What? I don't know. I still don't know that it is a 1 minute problem, but I'm sure. I'm sure this is very ChatGPT-able. So yeah, like I didn't really think about this part that much, but I'm actually happy that I got it. I thought I needed something crazier as well, honestly, but I'm happy that I didn't need to. And that's actually crazy. That I'm gonna, just for funsies, I am going to optimize this. Right. What is that? Less than Python less than function less than equal to or L equal. Like, is it just operator dot L? Okay, operator dot greater LE. Okay, so something like this, right? And actually we don't even care. And the sentinel value. Right, and then we just, that's it. If f of this, we Gucci, and everything else is the same, I think. So I didn't even, so we can just do calc, was it LE infinity plus calc of greater than equal to negative infinity. Might be the other way around, I don't know. Alright, yeah, so I guess this is much cleaner, right? I mean, because the code was just copy and paste, but I just took too long, frankly. I did the math really weird, and this -1 thing, I guess I just don't do that much with negative numbers. That I was just sloppy. And it's really tricky because I think the order operation of all these things is kind of a little bit awkward. But anyway, yeah, that is all I have for this one. That's all I have for this contest. Let me know what you think. Thanks for watching, and yeah, thanks for watching. And we could have done better, but I don't know. No wrong answers. I'm happy. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest, this explanation, everything in between. Keep it constructive. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.